Okay, recording.
Great. Okay, thanks very much. So without further ado then, thanks and welcome to the latest version of the Software and Computing Roundtable. The topic of today's meeting is going to be data management, something that we've visited before, but this time we'd like to take a slightly different angle. So we've got several speakers today who are going to present things from various points of view, and I'm going to let them do the job of presenting their own points of view themselves, which I think is appropriate for this kind of seminar series. So the first speaker is going to be Rosie, who I think is even prepared and has the technical setup to work with us and get us off to a flying start. And Rosie is going to be followed by Cedric, who will talk about Rucio at Belle II before we finish with John's talk on running Rucio at facilities and what that experience is really like. But first of all, then to kick us off, I'll invite Rosie to let me stop sharing the screen. Oh, no, okay, that didn't do it. This hopefully does. And hopefully Rosie can take over the screen share and tell us all about data management at SKA.
Yes, as soon as I can find that unmute button. So before I kick off, I will just remind everyone who's joined, I am in a public space. If the background noise becomes a problem, I suggest you just tell me and I'll go to my car, which might affect my bandwidth. So please do let me know if it's troublesome. And I'll apologize for everyone in the room with me here. SKAO and data management is a big topic. It's what I work on. I'm head of the data operations group at SKA, which sounds very grand, but we're quite a small team of just 5 people at the moment. The good news about that is that we don't have any data yet to worry about because SKA is a project happening in the future. But we're under construction now. So today I'll tell you a bit about the SKA regional centres and the sort of data management space that we're working in and how we've been investigating Rucio to address that issue. So SKA is a world-class radio observatory that will be built over the coming years and come online to be fully operational in 2028. It will consist of 2 different telescopes, one in South Africa and one in Australia. And the data that is generated at those sites is literally astronomical, but it's highlighted in this slide here. We talk about different data rates. Coming out of the antennas themselves, we have up to 2 petabits a second of data being digitized at the low frequency antennas in Australia, and a bit less than that, 2 terabits a second at the dishes in South Africa. That's not really usable data at all because it's very unprocessed, but it goes through a series of stages of being processed down the line to make it more and more manageable. And so one way to think about this, if you want to consider it in terms of kind of information theory, is that it's through a series of computational steps, it's changed from a very general data set of streams into a very specific set of data products. And the data products coming out at the end are what the scientists will be working on to do their analysis. So everything up to the green arrows is within the SKA Observatory construction budget. It's part of the telescopes themselves to do this data processing. The trouble that we have is how we would give users access to data products, which are around a petabyte a day from each site coming out of the data generation processes. And the vision that we have is very similar to the WLCG model, we think, that we want to have a distributed set of data centers around the world, giving users access. Can I pause there and check? Is the background sound too much for you?
It did increase a little bit, but it's okay for me personally. If anybody else wants to flag this, then now's an opportunity. No, I think we're good, Rosie.
Okay, sorry about it. Let me just switch to the next slide. So the regional centres are what I focus on. They don't exist yet, and they're not part of the funded SKA project. So we're in a difficult situation, but I think it quite closely mirrors the situation that worldwide LHC compute grid found itself in and what caused it to come about. One aspect to try and flag here is how users will actually control the data products that they're going to be given access to. You know, they need to specify what the data products are that will come out of the observatory, but they are not allowed access to the observatory compute, because those compute facilities are fundamentally part of the observatory. So if the processing in them slows down or is more difficult than was originally envisaged, the observatory will have to switch off operations because it won't have chewed through the data. So we hope that users will be able to specify the data products they need quite carefully ahead of time, and then those will be delivered to these network of regional centres. So I think the closest analogy in WLCG land, and I hope that's an appropriate thing for me to talk about in this particular group, is that the regional centres are a bit like the analysis facilities that I've heard about in not quite in WLCG, but associated with high energy physics workflows. So we hope that the SKA regional centres will be collaborative platforms in which users can work within groups to share data analysis, to do some iterative and flexible analyses on the products to deliver the science results that they want. Some of you might notice the Atlas plot that I put down here as an example of end science analysis coming out. So we want this collaborative platform to be available to the users, and as I said, that's really important for making a separation between the very prescriptive observatory processing and the much more iterative user-based processing. And as you're probably well aware, having access to globally distributed data products that are publicly available after a time period means that further science can be done by reusing those data products. So the fact that we need to have a global network of SRCs forces us into a paradigm where, because we have them, we can really use them to generate more science, to enable much better access than users might otherwise have if they had the current model of downloading your data as an astronomer and analyzing it on your laptop. You're not forced to have it in a public space there. Because we have to do it like that, we can use that as a kind of springboard to give us much better kind of amplification of the scientific impact of any observatory data product that gets made. So we need to make sure that happens, and we want to encourage interoperability with other observatories, and we can do that by looking at the International Virtual Observatory Alliance like definitions and standards. So I'll talk about data management a bit more in a minute, but the SKA regional centres will have to have many different capabilities that they offer their users and that they offer the SKA observatory as well. So distributed data processing, visualization and interaction of cubes, which might be up to 1 petabyte in size. So that's like 3-dimensional images, 1 petabyte in size. They'll need to be interoperable. They need to have scientific support for users, so help desks, helping guide users how to get their workflows to run well on the regional centres. And they'll need to support data discovery and science enabling applications. So typically like a Jupyter Hub notebook application, so that users can jump on board with their Python workflows. And central to all of that is a data management aspect, which we hope we can manage globally to ensure that there are replicas of data products in appropriate locations to enable users to access them where necessary, with a view to minimizing the duplication. So as I mentioned, it's about 1 petabyte a day coming out of each SKA site. You'll know that basically just corresponds to a 100 gigabit per second link coming out, which tells you an idea of the accuracy of that estimate, right? We think a 100 gig link is broadly appropriate. We may or may not have to fill it all the time, but at the moment, that's the ballpark we're working to. Those data products will need to be distributed globally, hopefully not more than 2 or 3 copies of each one, but around perhaps a dozen or so different regional sites, like central sites that are operating as SKA regional centres. And as you'll be well aware, if you don't get the replication model right and you have too many replicas and they're not well used, that corresponds to several $1 million of kind of wasted storage per year. And so that's why I'm very interested in getting a global view on the data management sorted out early on in the kind of design process of the regional centres, so that we really do understand that we can you don't need to have 6 copies of a data product. You can rely on different quality of service in different data centers and guarantee a level of collaboration between the sites and avoid the unnecessary duplication, but with a balancing act, because obviously more duplicates will mean less data transfers. And so you have to work out, do we want to transfer the data when it's needed? Do we want to transfer the users when they need access to the data? Or can we afford to make multiple copies? And we don't know the answers to all these questions just yet. So the way that my team at SKA has got a kind of foothold into this ecosystem has been through the ESCAPE project, and we've done that in what's called Work Package 2 of ESCAPE. That is led by colleagues at CERN, and some of whom are on the call. And that's been really powerful, because obviously the expertise that existed within CERN meant that they've been able to put together a data lake prototype for us to all play in, us being several different communities from astrophysics and astroparticle physics and high energy physics. And we've been able to jump on board with that, existing sites that understand how to interact with the Rucio framework, how to interact with FTS, how to play with CRIC, and users can come on and present our different use cases and try and see how well they map, how well those typically astronomy use cases map to the HEP-based ecosystem. And it's been really successful and useful as a learning exercise, and really great collaboration. I think everyone here probably is well aware of the sort of general way that Rucio works, and I'm clearly not the expert in the room on this, but I'll put up the ESCAPE data lake architecture diagram just to remind you that there are several services involved in running a data lake based on Rucio. You need to run the Rucio service itself, but it assumes that you have access to some kind of identity management system, some information system for understanding what the different storage elements are capable of doing, a file transfer service to actually mediate those transfers as they are requested by Rucio. So it's a many-layered system, and to come to that fresh without the knowledge that existed within the CERN team would have been impossible for a group of newbies. But the fact that we've been able to do it in ESCAPE has been really very powerful. I think the data management flow is fairly typical for ESCAPE. It's fairly typical for the rest of astronomy. And so I've taken a picture from the MAGIC telescope, which is a precursor for the CTAO. Effectively, we are often generating data products in remote locations with storage which is finite in size and which we don't want to give users access to. And we want to replicate that to multiple sites around the world. Once we know the replication is successful, we want to be able to delete the original copy. That's really powerful for just ensuring that we have, the ability to kind of like flexibly buffer what we're outputting. And that's obviously essential in an asynchronous workflow, that you need to have this ability to kind of like stretch and shrink. You need a bucket to pick up that data as it comes out and then trickle it out gently. So remote might be literally up a mountain, but in SKA's case, the data generation sites are actually in major cities, and they will host regional centers themselves. It's just that there'll still be Southern Hemisphere sites that we want to make multiple copies, around the world. And we want to be able to interconnect the regional centers with each other. So following on from the work that was done early on in the ESCAPE project, my team at SKA realized that although it has been great having a sandpit to play in, we wanted to be able to break it. So we deployed our own Rucio instance so that we could fiddle around with it, learn what the operational requirements are right from the ground up. How big a team do you need to run your own Rucio deployment, and what does it mean to be responsible for a Kubernetes cluster, and how do you think about authentication? So we have got that now up and running. We've got sites in Australia, South Africa, and in Europe, including some ESCAPE partners, but also some UK grid sites as well. And we are successfully running transfers automatically from our testing suite, on an hourly basis, of various different file sizes, just to check that the system is alive. And we've been able to deploy some specific tests. So we're particularly interested in how metadata can be used to pre-plan where you want your data replicas to end up. So the reason why that's important in the SKA context is you might have a telescope project which is awarded, say, 150 hours of observing time, and you know that it's going to spit out 10 different maps, all of the same part of the sky, but from different, different days, like different dates. And you want to make sure that those data products end up in the same regional center so that they can be easily co-added to get a nice deep image of the sky. So if you can have, in the simplest case, just a metadata field, which is the project code, and you pre-write a rule that says, listen up, Rucio, when you see this project code coming in, I want you to put replicas in Australia, South Africa, and 3 in Europe. Specifically, I want this site in London to be the one that is going to do the major processing. That's a really powerful thing for us to do, and we've run subscription tests doing that, and been obviously they've worked as anticipated, and it's just proved to our operations group in SKA that this is a sort of beneficial use case for Rucio in particular. And yeah, we've got long haul transfers happening. They're not particularly fast. We haven't done any tuning of them, but we do have successful transfers from Southern Hemisphere sites into our European sites. So we're really happy with that progress, which we started just less than 1 year ago. We deployed our own Rucio instance, and it was up and running very well by the summer last year, and now it's just in routine operations. We have a development instance and we have a production instance. It's not really production, but we separate the two, which allows us to play around. Currently, the team is working on looking at tokens and the sort of like tokenization of the Rucio ecosystem that we have, and finding it to be very much harder than we thought it would be. But I don't think that will come as a surprise to people here, but we didn't realize how difficult it would be. The reason why it's important is that if we have the current sites which are able to support X509, but we want to de-hepify the storage so that we can have new sites onboarding which have nothing to do with high energy physics, brand new astro compute sites, we need a more vanilla flavored way of doing the access. And I think that tokens is probably a useful way forward. So we will continue to investigate the Indigo IAM tokens as we move forward. So yeah, my team are very interested in all different technologies. My aspect when I look at this is always about how do you make it easy to operate. I want to be able to have a global picture of where the data products are and whether things are running smoothly. So I want things to be, easy to spin back up again, and able to give me dashboards with results showing what's working and what's not working. And so we are going to continue investigating Rucio. It's not formally adopted by SKA at this stage, but it's something that we are definitely continuing to test and prototype. Alongside Rucio, we have a prototype planned, which is something that's not got a very good name yet. It's just called the Storage Inventory. It's from a group in Canada who have it up and running astronomy data center. But that's a very different model to Rucio in that it's a decentralized model. It's a kind of subscription-based model for sites to say which data sets they're interested in, but there's no central brain saying you must have this data set. So it's kind of like a reversed way of doing it. It could work, but from an SKA perspective, I would much prefer to be able to say how safe is a particular data set. Oh, my data set's definitely well copied, well backed up. Are any of them more popular than others? Which one has last been? If something's gone stale, I'm just going to move it to the deep freeze and delete all of the active copies or all of the inactive copies on disk and just have it on tape. So I think that there's a lot of work to do around quality of service and popularity and savings that can be made by taking that into account. And yeah, we're also very interested in the metadata, and I flagged here that one of my team members, Rob, is now the lead of the metadata special interest group in Rucio, and he recently helped implement a change to enable ranged metadata searches in Rucio. So you could search for products with a particular date or something within a range, which has been a powerful improvement. So yeah, that's something that we are interested in. So that's my last slide. I realize I haven't solved any of the problems. I've just presented you with a whole bunch of much harder ones, but I'm happy that I'm in the company of people who do this probably on a much bigger scale than we currently have to.
Thanks very much, Rosie. Okay, so I think we should open the floor to questions now. And Tori, well, let me throw in I was very happy to hear. It sounds like you're using a Siri-based interface to Rucio, so you can just say to Rucio, "Hey Rucio, send my data over there." Is that a slightly facetious remark? Okay, let's open it up to more serious.
I would like that. Yeah, that would be great.
To more serious questions. So Tori, please.
Yeah, it was interesting when you said that tokens are difficult. Could you say a bit more about what makes them difficult? We're just about to start trying to use tokens in an experiment at BNL, so I'm curious.
Well, I think that's probably what makes it difficult. That if you folks in general from an astro sense, we've always assumed that everyone in HEP is like way ahead of us, and that it's all been done. And we realize now that actually the tokens it's still quite new. So it's not that you'll have trouble; it's that we realized that we were much closer to the kind of like leading edge than we thought we were. We thought we were just following along in well-trodden footsteps, but it actually is more innovative than we realized. So just to show you our complete naivety about it.
Is it tokens in Rucio specifically, or just getting used to tokens in general?
I think it is in Rucio. Actually, there are some aspects about it. Yeah, the site tokens have been fine, but not all storage technologies are equal as far as the token support goes, and that's a minefield for us, because when we started doing this work in Escape, we were completely unaware of the landscape of storage technology. So this is something that is very new and unusual for us.
Okay, thanks.
Okay, so next I see is Steve.
Yeah, so you briefly mentioned data lakes, which are of interest, but how have you found funding agencies to be with actually putting out money to actually buy storage for data lakes that's not being used by any specific particular experiment or whatever? Because it seems to be the funding agencies we deal with want their storage allocated and used. If you don't use any, you don't get more.
I think that's a good point. I mean, we don't have that issue yet because we don't have any data to put anywhere. When we are requesting data storage, like we will hope that different regional centers will pledge resources into a global pool, and some of that would be storage resources. But it won't be to support specific projects necessarily. It should be like a general SKA user storage pool, and the idea is then that it will allow central management of that. I take your point though that if it means that we deliberately ruthlessly delete data that's not being used, then there would end up being headroom in storage, and I think having empty space it potentially looks like it's wasted.
Funding agencies have horror vacuum, but so do users also with horror vacuum.
Yeah, exactly. We'll be able to tune it with the, in Rucio example, you can tune it with how greedy you want the Reaper to be. Do you set it to delete everything when it says it can be deleted, or do you leave it there just in case it's needed again? So there'll be options for that. But I would genuinely want to be able to say to funding agencies, actually, we didn't need that much storage, but we were under pressure for compute. So please next time fund the compute more. We'll have the ability to suggest what the roadmap should look like going forward.
Right, having that usage and the popularity reporting you were saying already is something that's going to be crucial for you, right? So next I see is Tamas.
Yes, thanks. So I'm happy to see this Rucio in production. So we have this test instance in Escape to try out Rucio, and we really like this concept. We need something better in KM3net. Obviously, we are stuck in the Stone Age regarding storage. But one of the biggest issues we had is basically the authentication. So getting these certificates is for some people, it took like weeks or months, and then the usage, getting the proxies done, etc. This is a big hurdle yet. So we only have like 2 people who have access, including myself. I was wondering, how do you deal with this? So do you use group certificates, or do you have other types of authentications or
Well, so
because
I mean,
you have this problem that the people are coming and going, like especially students, master students on a month basis, and also want to access data.
well, we will have the problem, but we don't yet have the problem. So, I mean, when I said we have a production instance, it's our team's version of a production instance. So there's still only a team of 5 people who have access. But you're quite right. I mean, this shift away from the need for X509 is something that, you know, new communities like KM3net and SKA are probably going to have to help push forward in the development, because it's something that is a hurdle for users.
Okay, thanks.
That's very good to hear. That something that seems to keep coming back with Rucio is that communities using Rucio tend to, at some point, end up contributing to the community effort as well, which is great. Next is Marshall.
Hi, hello. I just wanted to, we were looking at tokens as well, sorry, at Oak Ridge National Lab and we're not even as far as this is, so this is really good to see, but just the token part that we understood on Rucio is that, you know, that works with the API, and then the RSCs like Xroot, D, and Dcash can support it, but the client, the Rucio like CLI, was what there still needs to be work there. And then we were going to try to like look into if we could, you know, help, you know, like you were just mentioning, you know, give back, but that's just, you know, caveat if you're going down that route as well, something to be aware of.
Yeah, I mean, I wonder if Martin, I don't want to put you on, well, I am putting you on the spot, but did you want to comment on this? Because I think there is kind of groundswell for this.
Yeah, maybe I can quickly mention something. So Rosie, you're right. I mean, the token kind of evolution in Rucio is a little bit bound to the WCG timeline. And this is, I mean, you are kind of ahead of our timeline, basically. So this is not as advanced there as it should be. But I think like in the next months, this is something we want to focus on. There will be actually a token-specific meeting this Thursday where we discuss some of the improvements we have to make. In general, it's already working, and you can use tokens in Rucio, although documentation could be better, and this could for sure be streamlined to make the barrier of entry easier. But it does work, but it does not work in the sense of how you would expect tokens to work, to be really finely scoped, to give you specific access permissions for certain files. It's really right now largely a replacement of wherever you had X509 proxies, we use tokens. And that's not really how you should do things. But the second advantage of tokens will be that this barrier of entry, which is currently with X509, which requires this big kind of certificate infrastructure, which many communities just don't have, that should somewhat go away. I mean, it doesn't completely go away, but it will make it much easier to adapt an infrastructure with authentication properly.
Thanks, Martin. Okay, final question is from Miriam.
Hi, I was wondering if you could provide some links or maybe further documentation about this storage inventory system. I'm wondering about this because you said it was from a Canadian group. I'm actually on a partially Canadian collaboration, Super CDMS, and we are looking for possible data management solutions. And for us, I actually like this decentralized model.
Okay, yeah, I'll add it. I'll add it to Indico. It's from CADC, the Canadian Astronomy Data Center, folks. But I'll pop a link on the. Well, I'll pop a link in this presentation, and then I'll add it to the Indico as well.
Miriam,
okay,
if you're happy to stay unmuted for a second, would you like to say a few words on what's attractive about this decentralized model for you?
Well, I'm not really authorized to speak on behalf of Super CDMS, so okay. I'm not sure how much I should say. But basically, we have a situation right now where we have a central sort of processing pipeline, so to speak, at one of our participating labs. And then we also have, I guess, 3 other platforms on which we're trying to perform analysis And I think it would be good if like each of those analysis sites had like a subscription model. We don't really want to run all of the data management centralized through the place where our pipeline is located right now, because I shouldn't say too much, but we have a lot of trouble with that particular site, and we want to take as much burden off of it as we possibly can. So we have a situation where sort of what is supposed to be our central site is the weakest link in our chain, and is actually, you know, the 3 or 4 sort of so-called supporting sites that have been taking on more and more of a role of the computational burden.
Oh, great, thank you for sharing. That's really yeah, very much something that we like to hear in this kind of workshop environment, to get different points of view. I see Liz has just put her hand up, so maybe we take one final question.
Just a follow-up question, and that is, how big is your data set size problem? You know, I know that SKAs, we talked about petabytes, and I've heard other talks about from SKA, but no, I'm actually interested in the CDMS problem, because, you know, how much you can get away with centralized versus decentralized, I think could also be a function of how much data is moving around and has to be custodial stored.
Yeah, so I mean, basically, yeah, so I mean, from a super CDMS point of view, we are in the situation where what was supposed to be our central site is sort of just barely adequate to support our data needs, and we sort of ended up with more data, particularly from simulations, than we thought that we were going to have. And so really, when you're kind of close to the borderline case of, you know, just barely what you can handle on the central site, it gets ugly.
I see. Okay.
Yeah, I mean, I would say about the decentralized model is that it could work well if you didn't need to fully optimize the number of replicates. So if you have a small number of sites and you're happy that there be a central site that, you know, has a copy of everything and is the backup, you know, master, and the other sites can subscribe to it, and it doesn't really matter if they have to, you know, trigger a new download if they lose the data, then that model could work well. For SKA, I hope that we'll be able to have some kind of central brain that can help with the efficiency of storage. But I can see the attraction of having a decentralized system, in the sense that there's no single point of failure then either. There's not just one place which is the, you know, the cluster that's running the service, or not just one main database. So the database thing we might be able to fix by, you know, having a mirror that's a kind of like backup of the database in case it all falls over.
That's what we've already done. We've had to put up we've had to put up an entire mirror system. The other thing that we've run into, not to be too blunt about this, our central site is at an American national lab that will not grant access to computing resources to about a third of our collaboration, simply because of their country of origin. And so as a result, in order to make sure that they can access the data, we have to shunt them through one of our other supporting sites. And we're finding that, you know, we have to put more and more functionality and more data storage capability into those sites, because otherwise, well, as I said, a third of our collaboration can't access our own data, which is a completely ridiculous situation that somehow was not anticipated when an American national lab was chosen as our central site. And being Canadian, this whole thing is just completely mystifying to me.
Okay, I'm not sure if anybody wants to make a comment on that, but I can certainly sympathize.
I can sympathize, and I, you know, hope that this isn't the way of future international collaborations that are hosted at national labs. Let me just say that, because, you know, Dune is definitely being hosted at Fermilab, which is where I'm from. And we've tried to create international MOUs that would get around, give an exception to the rule you're talking about. I know very intimately what you're talking about, but we're not there yet. We do have an international MOU for the SBN program. In fact, I heard this morning earlier that it's finally gotten its last approval. So when you have one of these, it's not quite a legal document, but more like a treaty where each country who has a computing representative signs off and agrees to the rules of engagement. It almost sounds to me like CDMS didn't have that in place before some of these government regulations came down, and that's too bad.
That's exactly, we did not have that in place. And so I had to basically set up a mirror and an alternative platform using Compute Canada resources. I've ended up spending probably half of my time for Super CDMS over the past year or so, being the computing person who set all that up. It's been a huge drain on our personnel resources as well as on our funding and so forth, to actually be, taking chunks out of our budget to, get storage or whatever at whatever Canadian facilities. We've been using OSN, Open Science Network, as the other platform where we've put a lot of stuff. So basically, so we now have, whether we like it or not, a decentralized system where Compute Canada and OSN are taking on huge portions of the load because those are the only sites that collaborators can log into. I was actually just starting to look into this whole MOU thing with Slack. I'm not trained at all in the legalities of it. So it would be great if actually, if we could have a follow-up conversation about that and someone could explain it to me. I mean, first of all, I
was going to say that Slack should know about this because they've had to do exactly the same thing for Rubin Observatory. But with Rubin, it was early enough in the project phase that they were able to submit a change request and request more money from the agencies, basically saying, you're putting this new requirement on us. We need more money in order to fulfill it.
So we cannot do that. We cannot do that because our project phase is now complete. We're into operations phase and we've already had our operations budget cut. So we are, but anyway, I don't want to sidetrack the conversation.
I'm gonna be a little bit rude, so apologies for this, but I think just that it sounds like there should be a follow-up conversation between the two of you, actually, Liz and Miriam, if you have the time for that. Hopefully you can find a solution to that problem. I really cross my fingers because it's
a huge problem. I wouldn't promise that.
No, but well, okay, maybe a sympathetic ear might also be useful. This, right? Okay. So thanks again, and Rosie, thank you very much for your talk. I believe you have to leave the meeting fairly soon.
No, I'm all right. Yeah.
You're okay. Great.
Yeah,
okay,
I'll stay and listen. Thank you.
All right, very good. Glad to hear it. So let's, thanks again to Rosie, and we'll move on to our next speaker, and that's Cedric.
Okay, just first, can you see the slides?
Yes, do you want to go into presentation mode?
Yes. Is it okay?
Nope, it's fine if that's not possible, but.
Okay, let me try. Share.
It's probably the Rucio shared the window rather than the screen. And this is not the same window when you are in screen presentation mode.
Better?
Yes, that's perfect. Great.
Okay, let me start. I will talk about Rucio at Belle II. So, okay, the usual slide to start with. Just to remind you, Belle II is a bee factory based at Keike in Tsukuba, Japan. And it's an international collaboration of institutes over the world. Well, that's a bit smaller than the LHC experiment because we have only 1,000 collaborators. It's currently in data taking mode. We started in 2019, and the goal is to accumulate enough statistics to reach 15 inverse autobahn in the 30s. So that's the goal. So the early goal is just to accumulate statistics and to check that the super K B is able to run properly with background under control. And there are different things that we want to achieve, including tracking with high momentum particle identification, time-dependent measurement of CP variation. So I won't go into the detail, but okay, on this plot, you can see the current luminosity profile. And this plot on the bottom, this is the luminosity profile for the next decade. This is not the latest one. They have been changed recently, so you need to take this with a pinch of salt. But okay, the idea is okay, we are there, and we should reach 50 inverse autobahn in the 30s. So you can see between there and there, we will increase the volume of raw data stored by order of magnitude. So doing this will greatly improve the physics potential, but we need also to store this data. Yeah, and longer term challenge is about precision measurement and well, detection of new particle. So you can see on this plot, this is one of the primary results with the current data from Belle II. So this is with a 63 inverse femtobarn. So if you scale up to 50, you can see that you will greatly decrease the statistical uncertainties. So to address this future challenge, you need to have efficient computing, infrastructure, and tools. And for this, we use a grid like the grid used by the WSG experiment. So we have sites all over the world, in the US, in Europe, in Asia, and Asia Pacific. And okay, this is the computing model. So like the LHC experiment, we have okay, a tier 0 like, which is the KK center, and we have 6 other raw data center over the world in Europe and in North America. So to use the computing, we use the Dirac so-called interware. So Dirac, if you don't know about this is this framework that provide both the workload management and the data management that can provide both the workload management and data management feature. So as far as I know, Belle II was one of the first, was even the first to adopt Dirac after LHCb. And in addition to Dirac, we use different other services. The first one, so we used other services. First one was the LHC file catalog, the LFC that was developed 15 years ago. So that's something that was getting a bit old. The file transfer service, FTS, developed at CERN. Okay, this is still in use. We have a metadata service, AMGA, that was developed at the same time as LFC, and this one is also still in use. And for the authentication and authorization, we use the virtual organization management system, VORMS. But okay, as discussed in the previous talk, we plan also to move to token in the near future. So this plot is just to explain you a bit before the situation before Rucio. So we had our own Belle Dirac component for data management that was built purely for Belle II, and we had different components from Dirac. And well, this Belle Dirac was designed using the Dirac paradigm, so it was good for Belle II, but well, it had a few drawbacks that are listed there. So the first thing is that it was missing automation, for instance, for data distribution or deletion. There was also missing functionality, for instance, for the monitoring that was not using the latest and greatest tools that we have now, like Grafana or Kiban. Some of the components from Belle Dirac had also some scalability issue in case we wanted to transfer lots of data sets at the same time. There was some scalability issue. I also mentioned that at that time we were using LFC. That was something that was developed 15 years ago. So this is something that that was getting old. And well, LFC will drop its support when DPM is dropped, because DPM and LFC are the same. Well, behind this is the same thing. And well, the last but not least is that all development effort for implementing new things in Belle Dirac must come from Belle II. So you cannot expect any other community to provide this effort. So because of all this reason, there was a decision taken to replace DDM by Rucio. So I won't go into the detail of the transition that was described in detail in VCHEP talk and proceeding. So you can click on this if you want more detail. I just have 3 slides that I want to show that about this migration. So to ensure that this migration can be done properly, we had to develop a few things. In particular, we developed a new Belle II Rucio data management part that was providing the same API. So that means all the components, like the fabrication system, the production system. So these are our components from the workflow management system. They are able to talk to the data management using the same API as the previous one. So this was a big thing to implement to help this transition. We also implemented a new file catalog plugin in Dirac. So first in Belle Dirac, but this development was then merged to the vanilla Dirac. So now this can be used. It can be used by any other community using Rucio. So you can enable either the Dirac file catalog or the Rucio file catalog. And in that case, you can benefit from the feature from Rucio. In addition to this, there were the development that were mentioned in previous slide were the ones strictly needed for migration, but there were a few other that were done to try to improve to add new feature in order to be able to achieve the different workflow for Belle II. One of the first one was so-called chain subscription that was there to be able to export data from the raw data center to disk endpoint, then tape endpoint. One of the big things also was to implement a new monitoring based on Elk Stack. So this one I think will be presented by John in his talk. And we have also new monitoring demand for Rucio that help to simplify a lot the monitoring stack that was a bit complicated in Rucio. Then these new features now are available in Rucio, and they're already used by some community. For instance, in particularly this simplified monitoring infrastructure. And yeah, for the migration of this new development and the one mentioned in the previous slide were extensively tested for more than 6 months, including the infrastructure stress test. So after this, the migration occurred in January last year. It requested a few days of downtime to drain the grid and do the actual migration. But this was really a big bang migration. That means, okay, on the 14th of January, we were running Dirac as plus Belle Dirac as data management, and 5 days later, we were running all the features from Rucio. And yeah, I just did a copy and paste from an extract from the Belle II Physics Advisory Committee. Well, mentioning this migration. So yeah, it was received very positively by the collaboration, this migration, and yeah, it really helped to improve our operation and to decrease the the operational burden on people in the operation team. So there were a few things in this migration that were really challenging. The first thing is that, I explained in the first slide that we were in data taking months since 2019, but we had a small winter shutdown from end of December to beginning of March. And we were also constrained by the winter conference, so we had a tight schedule for the migration. So we managed to stick in this in this schedule during the winter shutdown. I also mentioned that we choose the Big Bang approach as opposed to a gradual transition that was done, for instance, in Atlas, where first the catalog was migrated, and after a few things were migrated. So that was really something also challenging. And you also have to remember that we are still in pandemic now, and most of the work done was done during this pandemic. And the thing is that, as I mentioned also previously, we have people involved in computing on different time zones, split over Japan, Europe, and the US. So that's very complicated to have every people at the same time to coordinate. So that was really something challenging. So, but even though it was complicated, we managed to get this done. So now, just a few words about the situation after 1 year. So these two plots show you the top plot show you the transfer volume over the last 1 year. So the transfer rate is about 11 petabytes and 35 million files. So if you compare this to the LHC experiment, for instance, Atlas, well, you can see that, okay, this is 1 order of magnitude smaller than what is usually moved by Atlas during 1 year. But you also need to take into account that, okay, this is a smaller experiment. And even if it's a small experiment, the current instance, the current Rucio instance is, as far as I know, the biggest Postgres instance of Rucio. And same plot for deletion, and you can see different deletion campaign. So, Rucio has been working smoothly during the last year, and we did, after the migration, a few more work to automate the deletion of transient data sets. So now this is done in production. So as soon as production is done, the intermediate data sets are removed. So that's also a big improvement for the operation team. And we have been enabling new feature, in particular in for end user tools. So now a few words about what we found good in Rucio. So first of all, a caveat for this slide. I'm just focusing on Rucio and not on the development part. This one will be focused on John's slide. And also, as a core developer, since I'm core developer from Rucio since its beginning, I'm obviously a bit biased. So I try to be objective in this slide, but okay, as I said, I might be a bit biased. So first of all, Rucio allowed to automate lots of the manual DDM operation. As I said before, there was one guy already dedicated to transferring the file. So this one, the fact that we moved to Rucio helped a lot in automating this. We thanks to Rucio, we also before also Rucio, we had only one raw data center that was BNL. So after Rucio, we are able to switch on multiple raw data center. So now it's working properly. With Rucio also, we benefit from the new development from the whole Rucio community. And we mentioned in the previous talk about tokens. So Martin mentioned that we will have next Thursday this discussion about tokens. So having a whole community that work on this is also good because we can really benefit a lot from this community. There are also good things for the end user, because now with Rucio we are able to enable functionality that were not enabled with the previous data management system, like the user quota or user dataset lifetime. So in that case, yeah, we can set lifetime for dataset user, and well, they don't need to care about deleting their dataset disappear when the lifetime is gone. Asynchronous data replication now is open for end user. That was not the case before, and also multi-threaded download that help to speed up download. A good thing also is the improved monitoring that is based on model tool like Elastic's Elk Stark with Grafana also. So using this new monitoring, we have now monitoring for transfer dation, space accounting that are very that are fit for our need. So that's very good. There are a few things that are less good. The first one is that some part of Rucio are still a bit Atlas specific. And one of the typical examples is the web UI. So web UI, there are still lots of things that are very Atlas specific. So the good thing is that things are now improving. For instance, the web UI, there is a current work ongoing to rewrite it from scratch using more modern tool, and hopefully when this rewrite of the UI will be done, all the Atlas specific thing will be removed. So yeah, things are improving. There's also a thing that that is not related to Rucio itself, the current way that Rucio and Dirac work together. And not only Dirac, but in particular Belle Dirac. The thing is that Rucio was initially developed by Atlas for Atlas, and having in mind that the workload management system is Panda, so there were lots of optimization in Rucio to be able to work well with Panda, but this optimization they are not there for Dirac. So now the way that Rucio is used with Dirac is sometimes not optimal. So this is something we need to work on. And in particular, to is the transition to Rucio. As I mentioned, we kept the old DDM API from the Belle Dirac, so that the production system is not modified. So because of this, again, we are not using Rucio in an optimal way. So there's currently work ongoing to simplify this, and yeah, hopefully after this, situation should be a bit better. The big difference also is the catalog namespace in Dirac. So Dirac has different catalog. The LFC was one catalog, and there was also another catalog that is the Dirac file catalog. But all these two catalog are hierarchical, so they are hierarchical, whereas the Atlas, well, Rucio as an Atlas as a catalog is a flat catalog, because you have this well, you have data sets that are collection of files, and you can have a collection of data sets, but okay, you can also use just plain data set and have a really flat namespace. So this is very different, and yeah, we had to use the Rucio in a way that was not really designed at the beginning to mimic this hierarchical structure for Dirac. And because of this, okay, we are also not using Rucio in an optimal way. But okay, the thing is that even if it's not optimal, the thing is working fine. So okay, we won't touch this hierarchical namespace in Dirac for now. And yeah, a few slides about some things that are not so good at all in Rucio. So the first thing is that there are lots of daemons in Rucio. If you know a bit, some of them have some names that are not very self-explanatory. So there has been recently some work to improve this and to have some meaningful name that would help people to, well, to better understand what are the different demands and how they interact with each other. And yeah, this daemon, they also support a lot of operation, and it's not only the daemon, but the server itself. And it's not easy to know which one needs to be enabled. And even for an expert, sometimes, okay, you wonder what this option is supposed to do. So that's something tricky, but again, here things is improving. Documentation is improving a lot. There was a lot of work on documentation to really document the different options. So things are getting better. And last is also that debugging can be sometimes tricky and require help from the developer. So yeah, that's the main big issue from Rucio that I have in mind. The next step for Belle, so now Rucio is going to drop completely the support for Python 2 in summer. So this was already done for the server more than 1 year ago. And the instance, the Rucio instance that we run at BNL now is fully Python 3 compatible since last year. But we need to achieve the migration into Python 3 for the client, in particular for Belle Dirac in summer. So there is a big work now ongoing that will require to move to the latest version of Dirac in the coming months. But we should be ready for this deadline in summer. The other thing is DOMA-related activity. So one of the big activity now last year for the WLCG experiment was the move to SRM and get FTPS. So since we were still busy with the migration from Rucio, we were not able to dedicate a lot of time on this migration, but now we are fully on it, and we expect to move to SRM-less and read FTP-less by summer. And well, as mentioned by Rosie, move to token is also something we are interested. And yeah, we hope that we will have fruitful discussion on Thursday about this. We also enable new feature in Rucio. So yeah, we just started to enable the popularity that we like to improve our data placement. We want to enable the file loss, the file loss and corrupted file recovery. So this is coming soon. And yeah, a few other developments that are needed in Belle Dirac. The first one is the tape smart staging. So currently, for the staging, we use manual. Well, this is a manual activity. So every time there's a production that needs to process data that is on tape, you have somebody that needs to stage the data manually. So we want to have something that is fully automatic in a carousel-like mode. Well, this carousel that is, for instance, used by Atlas. Accounting metadata is also something interesting for us. Currently, the space accounting is based on parsing the logical file name. That's poor man's solution. So it works up to a certain point because the naming conventions can change with time. So we really want to move to something that is more accurate, based really on accounting metadata stored in Rucio. So for this, we need to do some evaluation about metadata in Rucio. Yeah, I remind you that Rucio can support general metadata, and we want to run some stress tests to demonstrate that it can fit our purpose. So this is something we are currently running now. And with this accounting metadata in Rucio, we should have an accurate view of our storage usage. So in conclusion, Belle II now successfully managed to move to Rucio despite the pandemic and the fact that we are in data scheme mode. And we have been happily using Rucio for more than a year, and it really helped a lot to reduce the operational burden on our operation team. And the thing that this transition is really win-win situation, because with the move to Rucio, now we can leverage the experience for the whole community, in particular on all the new development, like the one from the WSCG DOMA activity, token, and things like this. And on the other side, many of the development that were done in the context of this transition are now already being used by other community, like the lightweight monitoring. So I would say that Belle II is quite happy about Rucio, and we hope that it will stay like this in the next years. And that's it.
Thanks a lot, Cedric, for that extremely unbiased and completely objective talk. All right, I see there are going to be a couple of questions. I think Rosie actually got her hand up first.
Technically, no, I was clapping, but I will put my hand up, but I won't ask the first question.
Right, okay. Yeah, okay, apparently my glasses are not as good as I thought. So Tori, I think in that case, you're first in terms of questions.
Okay, Cedric, is there anything either among experts or users that you guys missed from the old system? Anything it did better? Anything that might guide corners to make Rucio better?
Oh, that's I'm probably not the best person to ask, but because I was not really involved in the operation of the old system, so I cannot really answer that.
Yeah, I mean, I felt the pain there for a good year, not as much as Ruslan. Nothing that springs to mind. Sorry, it's a very good question. I really can't think of any functionality that we previously had that would be missing in Rucio. Not that I can think of. Rosie.
Yeah, I wanted to ask if your users have to upload data into Rucio after they've made more data products, or is it a kind of one-way street where they might do analyses and develop a whatever tiny output and then take it away? Is it going back in as well?
So most of the upload is done by the so when users are running job, this is the pilot that does the upload on the workload. There are a few use cases where user might want to be able to upload data directly on a storage element, but that's not very common. There are only a few. Well, this is not very common. I think this is the same situation in Atlas. In Atlas, it's only a very small fraction.
But I think that's maybe a question of a point of view. So if a user runs an analysis on the grid in Belle II, then their outputs will be uploaded to Rucio, no matter what their size. So it's the outputs of their analysis products, if that's just histogram files or but actually, sorry.
No, well, the thing that triggered the question was, I mean, I guess the data volumes would be tiny, but do you have to consider that when you're considering the user accounts, or do you have to have an understanding of the groups that the users are in? Where are they, to which quota would they be adding stuff back into the global inventory, if you like? Is it just not?
So currently, the quota is something we just started to introduce. So I mentioned it there. So we are starting to introduce quota, both local and global quota, to help managing the space. In the previous data management system, there was no quota. So currently we are slowly introducing this. Right now, the user, they are charged against their own quota. We have the possibility to have group and to have group quota, but right now by default, users are charged directly or on their own quota, no, not on their group.
Maybe another interesting point, so about the tiny outputs, and until recently there was a limit that if you ran on the grid, you could only run over one run at a time in one job. So that resulted, if you run over a lot of data, that you would produce a lot of tiny output files. So that did indeed, well, that's something that needed to be addressed to avoid that happening. Okay, any other questions? So I had one, Cedric, you were mentioning a lack of optimization between Rucio and Dirac. Could you give an example or two about that?
Yeah, that's well, I don't want to become too technical, but for instance, the download process is relying a lot on the hierarchical namespace. So you need to check that the directory exists, that there are files in this. So there are lots of interaction that are not needed in Rucio because, for instance, Rucio can, if you give Rucio dataset, it can resolve directly to the file, even if there are several layers of directory between the directory you want to download and the file. So these are the kind of things that I had in mind when I say that Rucio is not really optimized for running with Dirac. That's something we can address. We already did some change to be able to use this functionality of Rucio, but yeah, that's like this. So we have to accept that Dirac and Rucio, well, Rucio was not optimized for Dirac. It can work well with Dirac, but yeah, something you will have to keep it like this and cannot really be optimized.
This sounds like an implementation, how you've implemented, or what the implementation of the hierarchical data structure was made then. I mean, it's not necessarily the case that you need to navigate down a tree if you wanted to have something that was, in terms of implementation, really flat, and then you just present a hierarchical data structure, right? So that, was there another example where it's really the interface between the workflow management system or workload management system and Rucio, where there's some optimization that was done to take care of the way that Panda works, for example?
I
think I'm happy with that response, but
yeah.
Okay.
Okay.
I'll let you off the hook, Cedric, and we can maybe discuss that tomorrow, in fact, over a coffee.
Yes.
Are there any other questions? I do not see any other hands up. Okay, so in that case, thanks to Cedric again. I will roll back my comment that I would like to finish the meeting on the half hour, John, so don't worry too much. Apologies if I do have to drop out before the end of the meeting, but hopefully it's not going to run over too much. So, John, I will ask you to share your slides, please.
Okay, I hate to keep everyone here late. So
oh, we often go to 2 hours, actually, so we're done.
That's encouraging.
Just a harsh timekeeper.
Yes, some of us are.
Okay, so without further ado, John, give us the facilities perspective, please.
So I'll still try to speed through the slides because there's not a lot of time, and that's unfortunate because I had a lot of talking points for each slide, but I hope I can augment at least Rosie's and Cedric's talks with a facilities perspective of the Rucio service.
John, please don't feel obliged to speed up too much. If you have some talking points, we'd like to hear them, I think.
Definitely. Really want to emphasize that, John.
All right. Thank you for that. First, I'll emphasize the contributors to this talk, who are my collaborators at BNL in the SDCC and NPPS teams. Obviously myself, Hiro is my teammate at SDCC, and we also have Paul, Ruslan, and Cedric in NPPS. And just as importantly are the people who contributed information to this talk from various sites that I rudely asked on short notice for information about their instances. Martin was kind enough to provide information from Atlas. because Mario was on vacation, but I want to give Mario a shout out anyway. You know all about Belle II from Cedric, Eric at CMS, Brandon White, who manages the Dune and Icarus instances, and also is the point of contact for the upcoming Rubin instance at Slack. And we have Tim and Wenlong at RAL, managing the instances for EGI, GridPP, Swift, HEP. And Rosie gave a nice talk about global operations perspective, I would say, of data management. And I'll go over a few points about her instance that she gave me before this talk. And we have Matt also at Beano managing the S-Phoenix instance. So to quickly go through the Rucio instances around the world. I mentioned Martin for CERN. The Atlas instance is almost completely Kubernetes with the exception of
John, apologies for stepping in.
And load balancers.
John, you seem to be cutting out. You seem to be cutting out quite a bit. So you could try. Yeah, you could just try stop sharing video and see if that improves things.
A bit closer to the mic, if that's possible.
And closer to the mic. I can stop.
I also think it was the microphone. It was like noise cancellation.
Yeah, it wasn't. I heard a little bit of latency as well, so I'm not sure if it wasn't bandwidth. Okay, let's see.
I was worried about that earlier. I thought this might happen. Unfortunately, I've been too lucky with my home network over the last few years. It was bound to give out. So hopefully this is better.
Yep.
So for authentication, the CERN Rucio has 3 VMs handling all the auth calls. There are 3 production and 1 integration Kubernetes clusters. The separation is done to facilitate, obviously, updates of the software stack and cluster maintenance in general. 3 production clusters are configured completely the same way, with the same amount of REST servers and instances for daemons, and they all read the same flux config file, so they're identical. Each cluster is 16 VMs, 4 core, 8 GB, including the master node. The integration cluster is a little smaller, of 6 VMs, and this is used to validate new Rucio releases. And the database is on a dedicated Oracle 19C cluster with space at about 8 terabytes. So for CMS, everything in Rucio is also in Kubernetes under OpenStack. They have 2 clusters. One is 4 machines for development, and one is 8 for production. Everything related to Rucio runs there with one exception, which runs under a different Kubernetes cluster run by the CMS web project. The web UI is also under the Rucio cluster and runs its own X509 authentication. Everything is accessed via LX plus 8 at CERN, and the containers are all based on CC7. And the CMS-R, the offline Oracle instance, hosts Rucio data. So Fermilab's Rucio instances are deployed via containers in OKD. It's a cluster maintained by Fermilab Computing for general lab usage. Currently, those deployed containers are running Rucio 1.26.9, part of the LTS release. And they're custom built with some Fermilab and OKD specific modifications and policies. There are 2 production instances at Fermilab, one for Icarus and one for Dune. Both run in a hybrid model, which is using Rucio for replica management, and also either Metcat or metadata via sequential access systems for metadata cataloging. The databases are hosted by a separate group at Fermilab on a PostgreSQL cluster. In addition, Brandon has developed a generalized deployment framework for management of multiple Rucio deployments I included a link here to his framework if you're interested. It also contains image builds on a per experiment basis, allowing for complete independence between the Rucio versions used by disparate experiments. And all the necessary software is built into each of the Docker images. So at RAL, Rucio is running on Amazon EC2 Cloud VMs, with the main Rucio server running using a pip install. This is on a C1 extra large VM with 4 CPU and 16 gig RAM. And the daemons are running on a smaller, medium size 4 CPU, 4 gig RAM container. These specs seem to be more than adequate or perhaps even over provisioned for what the current services project as necessary. The main server is running Rucio 123.17. The daemons are 127.3, but they are quick to upgrade to new versions. And Tim is currently working on a Kubernetes deployment of Rucio instead to bring their instance more in line with the way other large experiments that are not Belle II are running their deployments. This is just a quick graphic of the current deployment and the envisioned redesign, the main points being the move to Kubernetes and adding database redundancy and failover. And this is a view of Wenlong's monitoring deployed at Edinburgh, based on ELK and deployed via Docker. So Rosie's focus was on global operations, but I can mention a few specs that might be interesting. SCA is running Rucio in a Kubernetes cluster, which resides in the UK STFC cloud, leveraging CERN for job pilots. For authentication, SCA is currently using X509 certificates, but they're playing with token authentication, as Rosie mentioned. And I should also chime in that, I think Rucio is actually a bit ahead of the game as far as juxtaposed against other services when it comes to transition to tokens. They're pretty much almost ready, but many services are not. So I think a lot of us are in the same boat here when it comes to token migration. So the Rucio instance for SPhoenix at BNL that Matt is deploying is currently 1 VM for the front end, 1 for daemon, and depending on how tests go and how the loads look, they may scale to 2 or more VMs each. These are VMs in Red Hat Enterprise Virtualization or REV. Rucio is deployed via pip to version 127.4. There's a separate Postgres database on a separate REV VM on a separate cluster, which again, depending on the specs and how testing goes, may move to hardware if necessary. This framework is sort of a vanguard in that a lot of our production services are not yet on these technology versions that I'm about to mention, being RHEL 8, which is relatively new for production anyway for us. And also we have a new deployment framework that we're using for new services like this one that are being deployed with these new versions of software being used, being Forming, Git and Puppet for deployment. So, well, so the Rucio deployment at Belle II, which is what I'm more intimately familiar with, mostly on, again, REV VMs. We have 2 VM clusters. In production, we have 5 RHEL 7 machines, 2 servers, 2 backend daemon hosts, and 1 user interface host, with 4 integration machines in a separate cluster. The database is Postgres on a separate hardware machine. Most of the code is deployed via Puppet and Git. Some of the development work that we've done includes integrating the Rucio service daemons fully with System D and Journal D. And as Cedric mentioned, we earlier migrated the service from Python 2 to Python 3 via pip. This is a network map of the front-end service and how clients interact with the service. It's on the LHC1 virtual network, which is a standard for WLCG user-facing services. We have a load balancer and a service alias for the Rucio instance. You can see BL Rucio on the left-hand side, via which users interact with the two front ends. And keep live D is used also in the setup to keep the two VMs synchronized and working together. And this is another view of the full service network, incorporating the connections between the front ends and the back ends and database. You can see the two front ends at the top, the two back ends kind of in the middle, and the database is off to the side. We can easily scale these out using Rev with new VMs. So Cedric talked a lot about the migration from Dirac in Belle II to Rucio, the reasons for that, and the features that it brings. To make this a reality, we had to do a lot of testing. So we kind of flooded in the beginning the test instance with concurrent clients to see how it would handle the load and to scale. In this test, we show that this was another scaling test where we used HTC Condor in opportunistic queue at a very high submission rate to test the load on the infrastructure. It showed us that the database was actually not the limitation as we expected. It was the front-end web service, in this case, which we were able to easily adjust by scaling out additional front ends in production. We also used this information to decide to split the database from the front end that was being tested and co-hosted on a single VM and scale out the, as I said, the front ends, and also put the database on dedicated hardware. So monitoring, Cedric mentioned a bit about this too, and the reasons that we chose to consolidate and improve the monitoring stack over what was in production for other experiments. The most notable being the employment of the Hermes 2 daemon and simplifying the stack behind that and using an ELK stack with Grafana for visualization and some InfluxDB data as well. This is a sample of the Grafana monitoring that we have for the Rucio service, specifically the front end. This is the service request monitor tool that Hero developed to parse the logs and quickly determine when a user is abusing the system with very large requests. This sends out, it identifies the user, sends out a notification, and if necessary, we can temporarily ban the user to salvage the service when it's under heavy load. So the database, I mentioned that it's Postgres. I didn't mention that it we found that the history table grows very quickly and that it requires monthly partitioning. And some of us feel that this should be a little more prominent in the documentation so that people aren't caught unawares as to when it, the usage spikes, as you can see in the bottom right graph. So some of the challenges, I think Cedric put it very well when he said that some parts of Rucio are a bit Atlas specific, and also that things are improving. But there's some details here about, depending on what deployment method you use, Rucio will expect certain files in certain places, even if those files don't exist after installation. Yeah, I think Cedric also mentioned that the UI has some Atlas-specific things burned into it. This is also being improved. We would also prefer that the user interface did not require direct DB access for read-only queries and data. It would be nice if we could just read from dumps or other replicated data for this purpose. And Cedric also mentioned that some of the daemons don't support the options that they claim. Honestly, these are, in a project this large and a software project this expansive, these are not really critical issues, and we're quite happy with Rucio, especially that we see that things are quickly improving whenever especially when we report them. But we have the privilege of great communication with the Rucio team, and they're extremely responsive. These are just some of the issues that we've reported as bugs and have been resolved. The last one, I'm not sure if it's resolved yet, but it's certainly been worked on. The one strange thing that I'll mention is that we had an issue where the first bullet here, where clients received a server certificate expired error when trying to retrieve Rucio data. And that was quite misleading because there was no expired certificate on the server side nor the client side. This happened to be the CRL process either hanging or taking too long and kind of tripping up Rucio. So for next steps, we definitely see some spots where we can improve the monitoring that we've already got in place. And as Cedric mentioned, there are more components and more optimization to be done with working with Dirac. At the facility side, we can definitely improve the automation and deployment of the services by improving our public code. And the kind of elephant in the room is moving to token-based auth, not just for Rucio, as I mentioned, but for other aspects of data management. And I think that's it. Yes.
Thank you very much, John. Okay, so let's open up for questions. And Tori already has his hand up.
Yeah, Rucio has Oracle in the back end for Atlas, and Atlas runs it at an enormous scale, and Oracle has been tuned to support that. Now, I wonder if it's an open question or is it understood whether you can scale with different backends like Postgres to an Atlas-like scale. As you're operating and doing scaling tests, do you encounter things where, oops, we had that tuned up in Oracle, but we have to do something in Postgres to solve the bottleneck?
Oh yeah, and we see that in Belle II for sure. And well, I should say that even though Cedric mentioned that Belle II is a relatively small experiment compared to Atlas in some ways, it manages a lot of data. So if I go back to the database stuff, well, this is one instance where, we saw that even though we've isolated Postgres on a hardware machine and it was performing well, the disk usage was shooting through the roof and we weren't sure why. So this, once we got the history table was the reason, we came up with a process to partition it, but we could have also scaled the database, and Postgres can be used for that just as well as an Oracle cluster.
So somebody who wants to use Oracle or wants to use Rucio at an Atlas-like scale against Postgres or some other backend shouldn't worry. It's gonna be okay.
Well, I can only say from the experience that we have in Belle II that it's performing quite well.
And if one of the Rucio team wants to pitch in on the,
I was going to say your legal counsel should probably step in here, John.
Yes, and that's why I'm saying only that. But we seem to be, it seems to be working well for us.
Thanks, John. Okay, you are cutting in and out a little bit again, John, now that you're sharing video. I don't know.
Okay.
Maybe related, but I think it was better before. Richard, I see, is next.
Yeah, Richard Jones at University of Connecticut. Wondering about how tied together Rucio is to the FTS layer that lies underneath of it. Saw someone had tried the idea of coupling it with Globus Online as the underlying transfer layer and using Rucio above that. I didn't see any updates on that in the last couple of years. I don't know if that project went dead or not, but that would be an alternate way to trying to struggle through this token transition, because Globus Online has sort of hidden a lot of that complexity and provides users with authentication through in common. Just any comment on that?
I see Matt is connected actually, John. I don't know if
you
want to make a comment on.
Say that I know that OSG is using this approach with OSG Connect for some of their VOs. We're also using FTS in Belle II, so we'll have to explore this eventually and come up with a solution. But it's obviously not just Rucio that's going to need token support.
Matt, maybe to comment on Globus. You're unmuted, Matt, but I don't hear you yet. I still don't hear Matt. I don't know if that's just me.
not just you.
Okay, sorry, Matt, we do not hear you. You could also make a comment in the live notes that Marcus sent a link to in the chat.
Will do, thanks.
All right, so are there any other comments or questions? Okay, I have one, John, which is that, so I see a lot of Kubernetes deployments being used, and yet BNL seems to prefer something a little bit different. Would you care to comment on that?
I would not care, but I suppose I will. We have tested and thought about deploying Rucio via Kubernetes. In fact, we considered that approach in the beginning. We had to do so much development that it just seemed better to have the files on a file system deployed via Python and pip, because of the issues that we were finding, and mostly Cedric was finding and fixing. It was just easier not to have to restart a Kubernetes cluster every time we were finding bugs in the beginning. I want to say that we're considering this for SPhoenix. I won't speak for Matt, and for Belle II, but when I do that, people get upset because we have a pretty stable deployment now. It's something we can certainly consider.
I would strongly urge anybody to avoid OKD if you can, if you're not employed yet.
Steve, would you care to elaborate more on that?
What?
Would you care to elaborate more on that?
There were just a lot of growing pains shifting from a non-OKD setup to the OKD setup we're in right now. It took almost a year to work them all out. This is for doing it Formula I'm speaking of.
Yeah.
Yeah, I know. Well, I know some people have deployed via OKD, and they're happy with it. I've heard other stories, not from Rucio, but other services and other experiments. So
right in general, not just for Rucio.
Yeah. Is that deployment knowledge actually captured and documented somewhere, Steve, to share with others who are trying to go through the same process?
Brandon has backpatched all the stuff that he had to fix into the main Helm containers, as far as I know.
Right. Okay. Okay. Thank you, Steve, for that insight. And are there any other comments or questions? I'm not seeing any. So in that case, then let's thank John once again. Marcus, I should really attend my next meeting. So could I hand over to you to introduce the next meeting in the series?
Of course, you can.
Thanks very much. And thank you, everyone. Thanks to all of the speakers again. Sorry, I have to leave a little bit early.
Thank you, Paul, for chairing the discussion. And I don't have any more to say other than the next Software and Computing Roundtable will be on April 5th. The topic which we will have is experiments starting up with contributions from both the HEP and nuclear physics community. And with that, I would like to end. But before ending, I would like to thank our speakers again. Thank you very much. This has been a really very interesting discussion on data management. And it was also really exciting to see at the beginning of the meeting that a topic as data management gets really that level of attendance with, I think we had as a peak 61 participants. Thank you very much to the speakers. Thank you everyone for joining and engaging in a discussion, and see you next then on April 5th. Bye.